Hello and welcome to today's webinar on how to transform your database into an engine of innovation. Today's event is brought to you by Nutanix and produced by Actual Tech Media. My name is David Davis and I'm excited to be your moderator for today's event. Now, before we jump into it, we've got a little bit of housekeeping we first need to cover. We want this to be an educational event, so we encourage you to use the questions box in the GoToWebinar control panel to ask as many questions as you have about today's topic. We have an expert on today's event who I'll introduce you to in just a moment, who will be doing a dedicated Q&A session at the end of the event and also answering questions electronically throughout the event. So make sure you get those questions in and get them in early. I also want to call your attention to a couple of handouts we have available for download right there in your GoToWebinar control panel under the Handouts tab. And one of them is a solutions brief entitled Unlocking the Value of Your Data with Simplified Data Management. So make sure you download that handout. We also have an infographic available for download there with some really cool facts. It's really well done, some cool statistics on there, and it covers how complexity hurts databases and how you can simplify it. So make sure that you download those two handouts. Download them now, check them out after the event, share them with your friends and colleagues. And without further delay, I'm excited to introduce today's presenter. That is Mr. Chris Papp, Solutions Marketing Manager at Nutanix. Take it away, Chris.
Hello and welcome to Transforming Your Database into an Engine of Innovation. My name is Chris Papp. I'm a Product Marketing Manager at Nutanix for Database Solutions. So as we jump into how we can transform your database into an engine of innovation, I want to kind of talk about a couple things on why it's relevant and why it's important to focus on databases and some of the problems that databases are running into today. By far, 80% of databases in use by 2022 will continue to be a relational database. The reason we talk about that is that there's a lot of talk, and rightly so, for MongoDB and cloud databases and NoSQL databases, but the truth of the matter is that still 80% by the study that was done by William Blair points to that most business critical operations for most enterprises, not all, will continue to use relational databases, and then 70% of those apps on there that they're using for Tier 0 and Tier 1 will be continue to use relational databases. This is important because it's an opportunity to jump in and get ahead of your problems, because the annual growth rate of structured data is going to jump into zettabytes over the next couple of years. And we'll jump into what that's going to look like from a cost perspective, not just from a dollar standpoint, but also from a management standpoint. And that we're going to continue to proliferate the amount of databases that are out there. It's just growing at an astonishing rate. It's not slowing down at all. And so now database administrators are having to do more. The accidental DBA, that's the systems administrator, systems engineer that inherited a database estate that is managing that environment, is, you know, a kind of a subject matter expert on all things, you know, in their ecosystem, but they're kind of inherited. They're just trying to keep it up and running, and the best practices, they're getting stretched thin. And we're going to talk about, you know, what that means in terms of a problem perspective and how we solve that. So we talk about the amount of data that we're taking care of today, and if you've been anywhere near any type of within earshot of any discussion when it talks about data, some of the key terms that are thrown out there are data gravity, you know, how the importance of data, how it circles, you know, how the environment and how business decisions circle around it, or the thought process that data is gold in today's economy. The more you know about your customers, the more you know about your business, the better insights you can make, the better the decision-making process is. With that said, that means that we're keeping all kinds of data. And it's just growing. And that's causing some issues, and it's causing some issues on two fronts. The first we'll talk about is from an architecture perspective, from a platform perspective. And the first thing that when I talk to customers, that we see a lot is the complexity of their environment when talking about traditional infrastructure, and that's characterized as separate SAN, separate compute, server environment, and virtualization, all segmented separately. Which, if you go back to like the growth that we're talking about, if you're running a couple of databases, that's fine, but in most environments, that's not the case. You have complexity that comes from individual silos that are created. So if you have a tier 1, tier 0 application with a database backend, what we usually see is that that's segmented with its own dedicated SAN, or most of it's dedicated to it, and its own servers. And it's segmented all together just so there's no stepping on it by other applications that could eat up IOPS and cause high latency. So that creates more infrastructure to manage. It means that, on the other hand, that we're having to make these large purchases that are coming way ahead of like trying to fit out for a 4-year solution. And it's time consuming, and upgrades are over time, especially when you have all these pockets and silos. Upgrades are going well past the maintenance window, eating up valuable time on weekends, and it turns into a troubleshooting nightmare. The other thing that we run into that's equally as important, depending on who you talk to, is that the performance. So if your environment is not performing up to speed, that equates to just as bad as being down or not coming up at all. So especially if you have a highly transactional database that's taking in a lot of orders and you're just not keeping up, that's actual dollars on the bottom line that's being affected. And what we find is that in these traditional environments, that most companies, or I wouldn't say most, but quite a bit of companies are living in a state where they just can't keep up with the speed of the business, and especially during peak hours, right? Like, it's, not all databases are created equal, and not all at all times are they leveraged to the full of their abilities. And we find that when it's needed and they need peak performance, they're just not able to get it, and that's affecting just the end user experience, and it's affecting the bottom line and the growth of the business. And then we come into the problem with being vulnerable. You have the problem of just missing upgrades, or upgrades that could be possibly security focused, or upgrades that were not supposed to be impacting to uptime, that all of a sudden now you're finding out that what you thought was going to be an hour downtime during off hours is now a 6-hour window. And so now you're bringing in separate teams, from the database team to the systems engineering team, compliance team, networking team, application owner, and you're trying to get them in at these off hours. And so you have a lot of eyes that are trying to make sure the environment's up. And it's in these very weird hours, or bumping up against production hours, or overlapping altogether, because the upgrade actually required, or the update required, a longer downtime than expected. The other thing that we see with this is, outside of an upgrade, is that it could be just the typical Murphy's Law of something goes wrong in the environment. It's just always going to happen in a data center, that you're going to have something go down. And we know that that's very, if you're not able to recover from it quickly, or your environment is performance is impacted as a result of it. If a drive goes down, it has to rebuild that RAID set, or it's just less capacity altogether. That's considered downtime, and we see that quite a bit with our customers. And finally, it's very expensive. So we talk about when we're having, if you've ever had to go through the purchase cycle of a SAN, or just a total purchased exercise for a large environment or a large initiative, you're generally looking at 3 to 4 years, sometimes 5 years in advance. That's especially true with SAN purchases, in that you have to size out over provision for performance capacity, as well as just general storage capacity, because you're not going to be able to just do a simple software update with these where you'll get more features and functionality or performance out of it. What it usually requires is a forklift upgrade, so you don't want to be doing those because they're very time-consuming and very expensive, and it's sunk costs and man-hours and capital costs. So it takes a lot. It's a large cost invested up front, which is not being leveraged. And you add to the fact that these environments are siloed and very segmented, So you have a lot of performance and storage capacity and compute capacity that is not being used in that first year, possibly, that another application could be using with their segmented. So it's very inefficient. It's a lot of maintenance cycles, and it's expensive from both a capital as well as an OpEx standpoint, because now you have a lot more man hours going into troubleshooting, maintaining, and keeping these environments up because they're all segmented. So we talked about the problems. Let's talk about how we provide value for databases. The first one is, and we'll dive into this after I give these high levels, we'll dive into how we do this, but we bring enhanced time to value and business agility. In one example of a customer that we have, we actually had solid evidence of when they were deploying to the dev and test environment, they were able to improve that deployment and accelerate that dev and test deployment by up to 10x. So we talk about bringing cloud capabilities to infrastructure. The same is true for databases. So customers expect now from the cloud to get, to be able to deploy in minutes versus weeks. They're expected to be simple and intuitive. They're expected it to be highly scalable with little to no ceiling on that. And so you get all those, and that applies to databases as well. So we're able to maximize uptime and security and slash downtime by up to 97%. And that's significant. And we call it one-click DR simplicity. You'll hear us talk about one-click DR, what the ethos of what we do within our UI and from a product management standpoint, engineering standpoint, is we want to make the product as intuitive as possible. We want to make that feeling the same as if you were running, like when you look at your iPhone or you look at your Android device, you're not expecting to go download an app and then or do an update and then read a 100-page manual on how to manage that. No, it's a click-through experience. You're supposed to use your expertise to kind of figure it out, and we do that. We bring the insights of your environment up very up front and center within our Prism UI interface or our Era Database as a Service interface, and you're able to see what's going on with your environment, like the hotspots, things that are going down, and how we resolve that to just the general performance and health of it. And so we slash downtime a couple ways. We do that with the one-click DR simplicity and the fact that you can fail over. It's built into the product. You have synchronous and asynchronous replication that we'll jump into. And then you also have the ability of it just being self-aware and knowing that when something is going to go down or it's not working right, it'll be proactive and resolve those issues. There's lots of high data availability built into the product, so the N+1, N+2, N+3, and so forth and so on. In terms of if you lose drive, you lose a node, you still have your environment up, kind of avoiding that unexpected downtime. And then finally, operational efficiency and reduced cost. We've proven with our customers and through IDC white papers, we have these data points back it up that we're able to reduce TCO by as much as 60%. And we do that by streamlining DBA operations. We have orchestration automation through our database as a service, where we're able to provision in minutes the multi-step process of deploying databases and patching databases, as well as scaling them out very quickly and effectively. So it's a lot of these tedious, error-prone manual operations are now rolled into an orchestrated framework that you can delegate off. So it's freeing the DBA and freeing the systems administrator up to do projects that affect the bottom line of the business versus putting out fires. And it's delegating those off to the teams that need it, so they're able to get these resources much quicker and faster. So we talk about from an infrastructure standpoint how we solve this. Very much an infrastructure company, but what does that mean for a database problem, and what does that mean from actual putting data into a table, and how do we resolve that from just being straight infrastructure? Well, we know today, we went over those problems of being complex, so expensive, and vulnerable that we went through. We collapsed that down for our infrastructure as a service, and we're able to take that into two ways: a scalable infrastructure platform and database as a service. And we collapse that into an environment that's simple, fast, cost-effective, available, and secure. So if we talk about the traditional database provisioning process, the flow that you're looking at right now has been highly simplified for the sake of just getting it to fit in this. But if you go through this process, you know it's not as simple as asking for a database and getting it. There's lots of teams involved. From the point that a request comes in from, say, a ServiceNow or something similar, you have to go through, and the systems engineering team then needs to deploy, if there's no existing database server, deploy a VM, deploy an OS, patch it, get it configured correctly, work with the storage team to, if it's a separate team, to getting the LUNs broken out, not only in a capacity format, but breaking out the LUNs so that they're configured. First best practice of that database engine that you're running. So logs are sitting on one type of storage, and the actual database files are in a separate type, and it's broken up effectively, and that it's at the right size, that when you do backups, that's giant backups, and speed is not an issue. And then once that gets added, then the DBA team needs to go on and install the database itself to best practice, which tends to be a very manual process. So if you're doing multiple databases for dev, test, and production, there's a lot of variables that could go on between those, and so which could affect like testing or production at the end of the day. And then you need compliance, and you need security to kind of look at these and make sure that they're up to stuff, and so on and so forth. So this is an example of where it's very easy to see with all the different teams, all the different hands involved, that the things that can be missed are where there's gaps and there's pauses in that. So if it's something as simple as a DevOps team requesting a database, that it could take, you know, sometimes a week or more to get that in if they're lucky. So it's very friction oriented. It's not aligning itself to the business and getting things out quickly and iterating in a very agile process, and increases time to market all the way through. So what we do with our database as a service, also known as ERA, we're able to bring a couple of features that that are focused on the DBA and the database in particular. First of those is one-click provisioning. The one-click provisioning provides us the ability to take a database, build it to best practices, not only per that database engine, but per the company as well, right? Build those the security compliance requirements and everything that's involved from a storage standpoint and an OS standpoint, and build that in so that you're providing this and orchestrating these steps and providing like a golden image, so to say, and roll that in and have that quite ready available. So once you do it once, you're able to wash, rinse, repeat, and deploy that out very quickly. So all these manual steps, now you've got them locked down. So the other thing that you're introducing is not only are you producing a database in minutes that's to best practices and to the best performance that you need, but it's also to per standards. Now you have a standard built out. So now you don't have these variations in database and instance type or patch level or OS level across the board, which makes it very hard to patch or to manage or to troubleshoot or to effectively test an application from production to, or from a test to production if it's on different versions of databases. You have the ability now to patch in the latest version. We can go out and specifically with Oracle in production and SQL as well. You can go out and set up a database patch train. So what that means is you set a level of which you want and test what your database is to be, and you validate and test and dev, make sure it doesn't affect the performance or requirements of production, and then you set a train to say, okay, now that we've effectively patched this in these servers and we've checked off that it's good to go, I want this server or this group of database servers to be patched to the same level, and you deploy that out and it's done. And database protection, so during the deployment process, the one-click provisioning, there's customization on that, so that if you wanted to segment your databases or you wanted to create microsegmentation in that, there's pre and post scripts that you can do for database masking that can be inserted into that provisioning process. And then finally, copy data management. What we talk about with copy data management is that there's so many copies of the databases out there that in a production instance, for example, you're looking at, for every one production database instance, there are 10 copies of that database out there. And then you add to the fact that the same IDC study has shown that 70% of companies, that enterprise companies that are running multiple database instances, they have as many as 200 in production. So, at that point now, you're looking at 2,000 databases that you have to manage, and it's usually with just a couple people to do that. And so that gets very expensive from a time perspective, but also a storage perspective, because most databases are going to be on high-performing, very expensive storage. And so if these are terabytes in size, very large, we bring the ability to now, with our APIs that plug into our storage, do these zero-cost clones and images of these data, or not clones, but snapshots. So clones and snapshots of the database, which are a fraction of the size of the actual production instance. So saving on storage and equating the cost. We bring the functionality of copy paste, the ease of that you have on a desktop. We're bringing that to managing and copying databases. So now something that would take quite a while to copy traditionally, a large database to another area, you can quickly and efficiently clone it in almost no time. So less downtime if you're having to quest that database and stop it. It's less downtime or no downtime at all, and you're able to copy it all together over very quickly. So from an infrastructure standpoint, we maximize database and application availability through non-disruptive one-click upgrades. We talked about that. So the ability to roll these out, you're not concerned, since we are a software company, we're an infrastructure software company. We go on OEM hardware, or we also have our own hardware. We can do it on HPE, Dell, Fujitsu, Lenovo. We OEM through all of them. But we are a software company, so just like if you own a Tesla, the new software upgrade that comes out that gives you more horsepower, we do the same thing with our features. If you roll it out, you're able to get the features through a software upgrade that will be non-disruptive, and you don't have to worry about taking a complete outage just to get these new benefits or performance benefits or security enhancements. So we have data redundancy without loss of performance. What we mean by this is we don't have the concept of RAID in our environment. And so because RAID is very time consuming to rebuild a lost drive, so obviously we've built that into having metadata across all the nodes. We do it much differently. With that said, the benefits of that are that if you lose a drive is rebuilt regardless of the size much more quickly than a traditional RAID set would be rebuilt. You also have, we talked about the data redundancy of replication of near sync, which has 1 minute RPO, async, which is 15 minutes, and synchronous replication, which is, I believe, a 10 millisecond requirement. You can't have more than 10 milliseconds latency between the two sites to do synchronous, but that is a 0 RPO, so we have that ability as well built into the product. We talked about simple integrated site replication, and we also have the ability of backup. So we have a large ecosystem of partners that plug right into us. Obviously, if you're a VMware environment, we run a lot of VMware, and if you're running that now, it'll work on us. But if you're HV, we have a growing number of backup providers that plug into us as well, that back up using our snapshots and our capabilities that can do that. We also have a new product coming out in the very, very near future called Nutanix Mine, which is secondary storage. So it's taking all the capabilities of Nutanix and putting that in a backup form factor that's very geared towards deploying quickly and then backing up your environment with extreme performance and restoring it with extreme performance as well. And then we have proactive self-healing, and that's done a couple of ways. One, if any errors are identified, it'll quickly identify those errors or hardware errors and get those resolved and flash you so you're not taking an unexpected outage. The other thing that we do is we have baseline. So if there's problems in the environment that are being flagged, and based on the baseline, it can then go identify the problem and resolve it very quickly. So see problem, fix problem. Very intuitive, and you can actually manage that within Prism as well. So we have a security-first design for infrastructure and databases. So again, if you see anything, if you've been near the news when it comes to any exploits or hacks that have been exposed, the last several that have come out that have been huge have been targeted as unpatched databases. And so one way we can address that is through Era, by using Era to quickly patch your environments. But the other thing is just from the lifecycle management of our entire platform, we always assess what the threats are. We build security from when we're designing products and incorporating them into updates. We also have the ability of when an exploit is identified, we can patch the entire environment through, again, our non-disruptive upgrades. We can do database masking and microsegmentation with the help of our flow, so to completely isolate that environment, and encryption and key management are key to that, that ecosystem as well. We have a huge partner ecosystem from a security standpoint that can also assist with the security first design for databases. So big for us from a standpoint and scaling is that we have what we call web scalability. So essentially, when we talk about taking the benefits of the cloud and putting them on premises, that's one of the big things we talk about. We can incrementally scale, or what we call fractionally consume, buy what you need now, because you can know that this way you're not paying additional for unused processors, or you're not paying for software licenses that are just sitting there for nodes that are being idle or storage that you don't need. Buy what you need, because there is not that law of diminishing returns that you get with traditional infrastructure. You can continually add on things like, in this example, kind of like stacking it up like a Lego blocks. You know how much capacity you can get on each node, and you can get it over time and just scale your environment out as demand increases, and scale on the fly. This has benefits for a couple of reasons. One is if you're doing it over a span of, say, years, as new technology updates come out, as new software updates come out, you can take advantage of that. If you were one of our early adopters and you had installed databases on like a hybrid disk type of environment, but now you're scaling up so much and usage has gone up, and you're putting different workloads on, and you have different types of databases on, and now you see the need for NVMe and RDMA. We have that ability now, so you can put those type of nodes with that capabilities and easily move those databases over to those new nodes that have those capabilities. So now you have that ability to scale up to that and get those new technology updates. We did a study a while back that we have on our website, that if you want to go check it out, where we had a third-party company test it out, where they started with one single SQL Server instance and then kept on scaling us up to see where the performance drop-off was. And as they scale this out to 6, 7, 8, 9 database servers and instances on those databases and different types of speed workloads, they saw the performance still scaled up with incrementally with the amount of nodes that you were attaching to it. So there was not that diminishing return on investment for performance that you see with traditional infrastructure. So what we also mean by that is we want to make sure that we have that same ESG lab that I was talking about. Also had this report where we had ultra-fast speeds of less than a millisecond per transaction for 4 nodes running the workload. For Oracle, we did have consistent latency as the number of instances increased, even at the largest scaling point. Latency did not exceed 1 millisecond. So that's important as you kind of roll out, because we always hear about in general with storage, IOPS is king, and I agree with that in some instances, but really what we have is latency is, I think, equal in terms of important, if not more important, because if you have high latency, you have long return times, and it can kill certain applications just can't handle those latencies when waiting for database responses, and then it ultimately results in an end user experience that is not palatable. Right. So if it's services that you're selling as a company, and that customer needs to jump on, do something quickly, and because your infrastructure is not able to keep up, their experience is poor. We'll help you get by that, and that's not a problem you'll have with putting your database environment on Nutanix. So kind of looping back around the Nutanix differentiators for databases, we there's three things I want you to remember for enhanced time to value and business agility. So we talk about linear scaling with zero forklift upgrades that you have with traditional infrastructure and zero downtime. So the ability to do an update or take an upgrade without taking on downtime. And then with our database as a service functionality, you have one-click database management that can provision, clone, patch, and refresh and backup in just a few minutes. Bringing in standardization, the ability to set a patch train up from test to dev to production in your environment, having 0-byte clones that are taking these huge terabyte databases and cloning them very quickly and with the ease of copy paste that you would with your desktop, very quickly and efficiency, so saving on time and capacity. Because of our fully integrated data recovery across the entire platform that's centrally managed through Prism Pro, we can maximize uptime and security. Again, anything that we do to proactive in nature, and our architecture is web-based architecture, web-scale architecture. It's very non-disruptive in IT operations. Our DNA, when you look at the history of our company and where this came from, is one of our founders was the lead developer on the Google file system, and our other two founders led the Oracle distributed computing unit. So the roots in distributed computing and kind of web scale at large, and that was built into the DNA of Nutanix. And finally, operational efficiency and reduced costs. Again, our DB as a service has that built-in database automation, including provisioning, copy data management, patching, and upgrade. And because of the efficiency of how we do our clones and snapshots, you don't have wasted storage. So we're able to reduce storage capacity and usage by all these database instances quite significantly. So how do we reduce costs with improved efficiency and productivity? Let's expand on that. So in some cases, we've had, in this case, an American healthcare provider slash their database licensing costs by more than half. So they were able to do that from an infrastructure perspective. They weren't over provisioning anymore. And then when they brought Nutanix in, they were able to do more with less. So the performance was better from a storage side, and from a licensing level, one thing that they figured out was buying high frequency procs that were the highest speed they could get, and just having less of them. So there was a less count that they were able to use. So, and then because they weren't over provisioning at the very start, with fractional consumption, buy what they need, they were only paying for, from a licensing perspective, what they were utilizing at that point in time. And then we talked about on the previous slide how much we can slash storage costs. We have some studies that we've shown we can cut storage costs by as much as 6x. It's a calculation that we have from our copy data management functionality, from the zero byte cloning that we can do and the 0-byte snapshots that we do. That production database might be 50 terabytes in size, but your copies of that, or the clones of that, are going to be much, much smaller if you're doing that using Era. And at the end of the day, if you're taking these manual error-prone operations and troubleshooting and a lot of these cycles out in just day-to-day operations, very important but mundane operations for your systems administrators and DBAs, and automating that and delegating that off, whether that's through Era or being able to set up infrastructure that's less management overall, you're saving time and you're allowing your DBAs and your systems administrators focus on projects that are going to expand the business, right? So forward thinking, bringing new technologies in, and listening to the business and able to respond to the speed of the business. And so through that, all those things we do, we're able to increase DBA efficiency and reducing OpEx by as much as 2/3. So just wanted to kind of wrap up. One of the things we talk about, a lot of these things on faster time to value through agility, and we talk about the ability to scale. Wanted to have a quick slide to show where it came from. It's the IDC white paper that we did on scaling and the increased revenue that could be as a result. Also wanted to show that the amount of staff time that can be improved on, or can be reduced, and the amount of staff time that can be reduced per storage deployment. When we talk about 5-year cost of operations, when us against legacy or before, pre-Nutanix, when a company's put Nutanix in, we've seen trends of 60% 5-year cost reduction supporting workloads on Nutanix through our efficiencies of storage and our efficiencies for an admin perspective and just general and use. And then you see an approximate $9 million savings from former legacy infrastructure. So if you're not buying more of that legacy in, you're leveraging what you have better. That actually has a tangible capital cost that you'll see what's saved over the years. Then again, based on the type of benefits that you're getting per the organization and what you're doing, this was based more on database as a service and the benefits that you see over time through IDC, and that's $4.2 million of savings that could be invested in other technologies when deploying Nutanix versus legacy infrastructure. One of the key examples that we show a lot with customers that we've had a great experience is Valpak was having problems. They're a very large company, marketing and advertising. You've probably gotten something in your mail from them at some point in time. But they were having problems keeping up with the business when they needed performance at key peak hours of usage, and then they were also having problems with their deployments and upgrades with legacy. When they put us in, they saw a 10x faster deployment times and 8x performance improvement, and they were able to cut monthly management time from 180 hours to just 2 hours. So some extreme benefits that they saw right off the bat. And then we also have an example of a global gaming company that went from 2 weeks to 3 days to refresh an entire environment. So that's massive. And then 2 minutes to stand up a new server from 2 weeks. So that equated in that ease of use and that fractional consumption that they saw. They quickly were able to address this in their Oracle database environment, which equated to improved database availability. And then also from a cost standpoint, they freed up $10 million in database licenses just by using what they needed and sizing appropriately or right sizing their environment. And doing more with less. So just as a cap off, we do have a lot of resources available. Went through a lot of information, but depending on what type of solution you're running, if you're running SQL Server on Nutanix, you go out to nutanix.com solution/SQL Server, or Oracle, it's the same thing, solution/Oracle. SAP is huge, and then we also have a business critical app sites that on our solutions drop down, you'll see that. Click on that, and you have case studies, examples, and resources and white papers that you can get access to as well. So please feel free to ask any questions. And if there's no more, then thank you for your time. I'll stay on for a little bit as well to take any questions you may have. So one of the questions that has come up is how do we license Era? Era is licensed per vCPU of the instance being managed. So if you're only managing our database as a service functionality, which is Era, you're only doing 10 instances. You're just only going to be licensing those 10 instances, regardless of how many databases are in your environment. So that's how we manage that. Another question that comes up in terms of cost savings for databases is, can we segment, especially for Oracle, an environment, if you have multiple clusters, how can you do that? Or if you can segment like an LPAR type of functionality. So Oracle is very specific on licensing. What we recommend in those cases, especially if you have a large Oracle estate, is that you can do data or VM pinning or database pinning within the environment. Oracle generally doesn't respect that. They want, if it's in a part of a cluster, you got to license everything in that cluster. So we recommend, if you have multiple database servers, keep them all to one cluster, or Oracle servers, keep them all to one cluster, and then specifically right-sizing that. So it's not like if you're on your legacy infrastructure, if you have 15 servers on a legacy environment, and each of those are 4 procs. you have 60. That can probably be reduced on our environment with using the highest frequency procs available, and then so you're getting better performance, and then storage is being better, and the environment in general is better high performing from a legacy environment, and then right size it from there. And so there's cost savings by right sizing, and then kind of keeping it just for a specific cluster. So just licensing what's based on that cluster. So the last question that I see is what database engines are supported for our database as a service. So right now we support Oracle, SQL Server, Postgres, and MySQL. We do have coming up in our roadmap, MongoDB is coming up. That was announced at .next, as well as support for SAP. And if there's no more questions, then we'll call it a day. And thank you for attending the webinar, and I appreciate your time. Thank you.
Great webinar, Chris. Really great info. Thank you so much. Let me go ahead and share my screen because actually everyone is a winner today. Instead of announcing one single $300 gift card, everyone is a winner today. A single $5 Tango gift card going out to everyone who attended today's live event. Those will be coming from prizes at actualtechmedia.com. Please allow 2 to 4 weeks to receive your gift card. And there's the email address you can email if you have questions after you've waited a couple weeks to allow for delivery. I want to thank you to everyone in the audience for joining us on the event today. I learned a lot about maximizing database performance and how hyperconvergence can help. I hope that you learned a lot as well. I could see some great feedback coming in from those who enjoyed the webinar, so thank you very much for that. Don't forget to download the handouts that are available right there in your audience console. There's a solutions brief and also a really cool infographic with tons of great statistics. And of course, visit Nutanix.com to sign up for a trial, do a proof of concept, learn more about how the Nutanix can help you to maximize your database performance and make running databases more efficient in your IT organization. Again, thank you to our presenter, Mr. Chris Papp. Thank you to Nutanix, and thank you to everyone in the audience. See you next time, and have a great day.